7.4. Solving polynomial equations in factored form. So what have we been talking about in 7.1, 7.2, 7.3? What? Polynomials, right? We've added and subtracted them, and we've multiplied them, right? Y'all remember that? Okay. In 7.5 and a little bit in 7.4, we're going to do this thing called factoring, which is the reverse of what we did when we multiplied polynomials. Okay? You know how we multiplied them out? And we got a big polynomial. We're going to get a big polynomial, and it's going to want us to break it down into its two factors that would multiply to give that, if that makes any sense. So today we're going to look at equations that are already factored out for us. So we're not going to factor today. We're just going to solve those equations that are already factored for us. Okay? So let's get into it. A polynomial is in factored form when it is written as a product of factors. Polynomials in factored form when it is written as a product of factors. So the past few sections, we've been given problems like these over here, correct? And we multiplied them out to get our standard form over here. Everyone okay with that? So they're starting out in standard form, factoring them, and getting it in the factored form. So today they're already going to be factored for us, so we don't have to focus on that today. We're just going to be solving equations of this form over here, this factored form. Everyone okay with that? When one side of an equation is a polynomial in factored form, so something of this sort over here, that's factored form. When one side of an equation is a polynomial of that form, and the other side of the equation is 0, like that, we use this thing called the zero product property to solve the polynomial equation. The solutions of a polynomial equation are also called roots. And so on the next slide, we will see what the zero product property is. But I'll read that again. When one side of an equation is a polynomial in factored form, like here and here, and the other side of the equation is 0, so it equals 0, we use the zero product property to solve the polynomial equation. The solutions of a polynomial equation are also called roots. So you can call them solutions or roots of that polynomial equation. Am I good to move on to the zero product property? Okay, I'm waiting a second. Am I good to move on now? Okay. Here's the zero product property. If the product of two real numbers is 0, then at least one of the numbers is 0. I feel like this is an easy property to understand, but a lot of people overthink it. So, here it is algebraically. If A and B are real numbers, and A times B equals 0, one of these numbers has to be 0, right? For them to equal 0, because anything times 0 is 0. So I know either A has to equal 0 or B has to equal 0. Right? Or they both have to equal 0. Everyone okay with that property? So if I've got two things being multiplied together, one or both of those things must be 0. Right? Does that make sense? Let that sink in a little bit. I want you to write it down. Two things are being multiplied together. one of those things must be 0 if they're equal to 0. Two things are being multiplied together and they equal 0. One or both of those things must be 0. That's what the zero product property tells us. Which I feel like makes sense. Everyone got that written down? Okay. So when I'm given an equation, I've got to find out what values of that variable would make that equation true. So if that equation equals 0, I'm going to use this zero product property to determine which values make that equation true. So essentially, what values make that equation equal 0. Okay? So, here's our example 1. A and B. Solve each equation. I've got 2x times x minus 4 equal 0. 2x times x minus 4 equals 0. Got to use our zero product property here. Do I have two things being multiplied together? Yes. Do they equal 0? Yes. So I can use my product property here. So what must equal 0? 2x. So here's what I'm going to do. I'm going to set 2x equal to 0. What else might equal 0? Not x. Not negative 4. Put those two things together. What's in parentheses? X minus 4. So I've got 2x and x minus 4 being multiplied together, correct? I know one of those things must be 0, one or both of them, right? So I'm going to set those two things equal to 0. Those are called factors because this is factored form, right? So I'm going to set the factor 2x equal to 0 and x minus 4 equal to 0 to see which values of x would give me 0 for my equation. Now I've got two equations here. I'm going to solve both of these for x. So here, for 2x equals 0, how would I get x by itself? What? Divide by 2. X equals, what's 0 divided by 2? 0 divided by 2? 0. There's one of my answers. X minus 4 equals 0. How do I get x by itself? Add 4 to both sides. X equals, what's 0 plus 4? 4. There's another answer. Everyone okay with that? Now, let's kind of check our solutions. Let's say we plug 0 in up here for our x's. What would 0 minus 4 give me in the parentheses? Negative 4. And then 2 times 0 outside the parentheses. What's 2 times 0? 0. And then 0 times negative 4 would give me 0. So does 0 equal 0? Yep. So I know this solution checks out. X equals 0 is for sure one of my solutions. Or one of my roots, as we saw earlier on one of the previous slides. Now let's plug 4 in. 2 times 4 would give me what on the outside? 8. I plug 4 in for this other x. What's 4 minus 4? 0. What's 8 times 0? 0. Does 0 equal 0? Yeah, so does 4 check out? Yes. 4 checks out as a solution as well. Does everyone see how we use the product property? We have two things being multiplied together. So I set each factor equal to 0. Solve those equations. Okay? So knowing all that information, let's figure out letter B. I've got x minus 3 times x minus 9 equals 0. Raise your hand if you can help me out here. What do I need to do? Raise your hand. Yeah. Okay, what are my factors here? So I need to do what? Minus what equals what? X minus 3 equals 0. Very good. What else? Yeah, very good. X minus 9 equals 0. Does everyone see that? Got these two things being multiplied together. X minus 3, x minus 9. Those are my two factors. So I need to set those equal to 0, and these will give me my values of x that make the equation equal 0. So the first one, x minus 3 equals 0. How do I get x by itself? Add 3 to both sides. X equals 3. There's one of my possible solutions. X minus 9 equals 0. How do I get x by itself? Add 9 to both sides. X equals 9. Now let's check our solutions, make sure they work. Let's plug 3 in. 3 minus 3 gives me 0. 3 minus 9 gives me 3 minus 9? 6. Negative 6. 0 times negative 6 gives me 0. Does 0 equal 0? There it is. 3 checks out. You okay with that? Plug in 9. What's 9 minus 3? 6. 9 minus 9? 0. What's 6 times 0? 0. Does 0 equal 0? Yes, 9 checks out as a solution as well. Any questions on that? Does that all make sense? Now on your assignment, if it tells you to check your solution, I do want you to check it on paper instead of doing it like we just did it. It didn't tell us to check it on this example, but I wanted to go ahead and check it in our heads. But if it tells you to check your solution, do it on paper. Everyone got it? Can I move on? When two or more roots of an equation are the same number, we say the equation just has repeated roots. When two or more roots of an equation are the same number, so when two or more solutions of an equation are the same number, the equation has repeated roots. Can I move on? Okay. Hurry up. Okay, let's move on. I'll come back to it if I need to. I'll come back to it if I need to. Solve each equation. Letter A, 2x plus 7 times 2x minus 7 equals 0. Someone want to raise your hand and help me out? Raise your hand. Yes.
2x plus 7 equals 0.
Okay. That's one of my factors, right?
2x minus 7 equals 0.
There you go. There's my other factor, 2x minus 7 equals 0. Everyone okay with that? Everyone understands my two factors are 2x plus 7 and 2x minus 7. They're being multiplied together. So I know one or both of those must equal 0 since the whole equation equals 0, right? Now we need to solve each of these equations. First one, what's my first step to get x by itself? No. Subtract 7 from both sides. What's 0 minus 7? Negative 7. Now, how do I get x by itself? There you go. Divide by 2 on both sides. Negative 7 divided by 2, does that give me a nice whole number? No, I'm just going to leave it as a fraction. Can that be reduced at all? No. So negative 7 halves. Everyone okay with that? Next one. What's my first step to get x by itself?
So add 7.
Add 7 to both sides. 2x equals, what's 0 plus 7? 7. How do I get x by itself?
Divide by 2.
Divide by 2 on both sides. X equals
X equals 7/2.
7 over 2. Very good. Okay with that? If I plug in negative 7 halves, it's going to give me a 0 in this first set of parentheses. So 0 times whatever number I get here is going to be 0. So that's a true statement. That one checks out. 7/2, when I plug it in here, I'm going to get 0 in the second set of parentheses. 0 times whatever over here, give me 0. 0 does equal 0. That one checks out. Do I have any repeated roots here? Do I have 2 of the same number? I do? No, I don't have any repeated roots. Negative 7/2 is different than 7/2. So no repeated roots here. We good with that one? Can I erase and move to letter B? Letter B, x minus 1 squared equals 0. What's another way I can write x minus 1 squared?
Wait, what?
What's another way I can write x minus 1 squared? Yep, x minus 1 times x minus 1 equals 0. Everyone okay with that? Okay, so what are my two factors here? X minus 1 and x minus 1, right? So I said each of those equal to 0. How do I solve both of those? Add 1 to both sides. For both of them, what does x equal? 1. Do I have any repeated roots? Yep, I'd say it has repeated roots of 1. There you go. Any questions on letter B? Or I guess you could say x equals 1. And can I erase and move to letter C? Letter C. X plus 1 times x minus 3 times x minus 2 equals 0. Raise your hand if you can help me out here. Someone who hasn't answered yet. X plus 1 times x minus 3 times x minus 2 equals 0. Raise your hand before I call on someone. Yes? Okay. What else? Very good. Anything else? Very good. This one's just a tad different because I have 3 factors. So if I've got 3 things being multiplied together and they equal 0, the 0 product property still applies, right? Either one or all of these have to be 0, right? For the whole equation to equal 0. So I just take all my factors, set them equal to 0. Solve them for their little equations. First one, x plus 1 equals 0. How do I get x by itself? Subtract 1 from both sides. X equals? Negative 1. Okay, x minus 3 equals 0. How do I get x by itself? Add 3 to both sides. X equals? 3. Very good. X minus 2 equals 0. Add 2 to both sides. X equals 2. Do I have any repeated roots? I do? I've got 2 of the same number?
No, yes.
Where?
1 and 1, 3 and 3, 2 and 2.
For the x equals?
Oh, no.
Okay. So, if I plug in negative 1 anywhere, is that going to make the equation true? Yeah. Negative 1 checks out. If I plug in 3, will I get 0 anywhere? Where? X minus 3. It'll give me 0 in the second set of parentheses. 0 times all that will give me 0. So that one checks out as well. Will 2 make the equation true? Yeah, it'll give me 0 in the last set of parentheses. So I know it checks out. Any questions on that? So if I had 5 things being multiplied together, I'll just take all 5 factors, set them equal to 0. Right? If the equation equals 0.
Yes.
If the equation does not equal 0, I can't use the zero product property. I got to do something else. Okay? Any questions on this example 2, A, B, or C? Okay, move on. There you go. Page 365, numbers 3 through 24 all. Page 365, numbers 3 through 24 all. Any questions about my recording before I end it? All right.